Let's say you get an order in from your client and you're asked to configure dynamic network address translation. They would like to go to the internet. There's a few assumptions that we're going to be working with for this demonstration. Firstly, that they give you their IP addresses they would like used and their NAT range. And secondly, that this portion of the ISP router and internet are configured by the ISP. So we will not be configuring internet outbound traffic. First thing we need to do is make sure everything's connected properly and has the correct hardware. So let's open up our router A and our ISP router windows, and let's just make sure that we get the proper hardware installed. Switch the router off, add a serial and Ethernet switch, and switch it on. And we can do the same for the other one. Serial, Ethernet switch, and switch it on. Now we need to connect the devices. So normally we don't configure the internet to ISP connection, but for us, let's use an Ethernet, 2 gigabit Ethernet. If we did it the other way, it would if we did it with the automatically choose connection type, it would go with serial, and this we just want to be copper. So now we can use the automatic connection type to establish connections on all other devices. And notice that the switch to server connections are automatically up. This is because switches are sort of really nice, kind of plug and play a little bit with their Cisco Discovery protocol. So the type of hardware we're going to be using for this demonstration is a 1941 router for each of these, the Cloud PT, and for the switch, we'll use the 2960. These are the Cisco standard devices. So now we'll need to make sure that we are configuring the IPs on the servers. So let's open our web server and FTP server configuration. And go to desktop, IP config. And the client would like their FTP server to be configured with 192.168.12.2. /24 is CIDR notation. This tells us how many bits are ones assigned to the subnet mask. So with 24 bits, we know that that would be 3 whole 8 octets, because 3 times 8 is 24. If we sum 8 ones in binary, we get 255. So we know that the subnet mask must be 255.255.255.0. The default gateway will be the IP address of the router A gigabit Ethernet interface. This would be 192.168.12.5 according to the network diagram. Now let's make sure that we configure the web server in much the same way. This one instead will be 192.168.12.1 with the default subnet mask for class C address, and 192.168.12.5 for the gateway. Once those are configured, we can sort of hide those, as we will not be needing them until the end where we test with a ping. Now we need to configure the interfaces on the routers themselves. Let's start with the ISP router. So go to the command line interface and hit enter. If it would like an initial configuration, just select no and hit enter. Enter again, and we are in the command line. First thing we need to do is enter the enable mode and then the configure terminal mode. We're going to rename this host name on the router to ISP so that we do not get confused which router we are accessing from the terminal. Now let's go to the interface which connects the ISP router to router A. That would be interface int S010. This IP address will be IP address 200.95.95.2. And same as before with /24, we know that that's a default subnet mask for a class C IP address. So 255.255.255.0 and hit enter. Now we can type no shutdown to bring this line up. And we can see that the state has been changed to down. And it is still red on the network diagram here. And this is because we haven't configured the other side. So let's exit. And we can actually use Control-Z. And let's just save these changes real quick. So we'll copy the running config to the startup config so that if we ever lose power to this router, it will revert back to these changes that we just made. So enter, enter, and that will build the configuration back out. Now we need to do the same thing on router A, except this time it will be just a little bit more complicated. For router A, there are going to be several additional steps that need to be performed to configure the network address translation. This needs to happen before any of your private IP addresses are shared to an external source, something outside of your control and outside of your physical location, such as the ISP router and the internet. The whole point of NAT is to sort of hide your private IP address behind a public IP address so that someone cannot reverse your connection on you. So same as before, enter, select no, and enter again. We'll go to enable, configure terminal, and again, let's just rename this to router A so that we don't get confused at which router we're in. Now let's configure interface S010, which is the line facing the ISP router. And the IP address we have based on the network diagram is 200.95.95.1. And we know it's the default subnet mask for class C address. Now when we type no shutdown and hit enter, we'll see that the line is now green. And it is now configured to be up. Now we need to do the other interface. So exit. And let's do interface G00. And we know that the IP address our client would like us to use is 192.168.12.5 with the default subnet mask address. Now when we type no shutdown and hit enter, we can see that the line is now green and the connection to the route, or the connection from the switch, will take a little bit to go green. This is because it is pending the Cisco Discovery Protocol to be completed and for that to be added to the switch's tables. And that will happen all automatically for you, but you can configure switches manually if you would like. But that is outside the scope of this video. So we'll continue configuring the NAT. Once we've configured the interface, let's go exit. And now there are a few commands we need to enter. the first thing we need to do is to configure the IP NAT pool. This is our pool of public addresses, which can be randomly assigned to each host. So to start, let's do IP NAT pool, and let's just name it my pool. Let me get the router back up so we can see what we're doing. There we go. Apologize for that. So IP NAT pool, and let's name it my pool. The client would like us to use the NAT range 200, 95, 95, 100 to 200, 95, 95, 150. So let's do that. 200, 95, 95, 100 to 200, 95, 95, 150. Now we need to enter a net mask, which has /24, so we know that that's the default subnet mask for a Class C IP address. And hit enter. Now we need to configure a standard access list. To do that, type access-list. And you can choose any number from 1 to 99. It's sort of just a name for the access list, if you will. So let's do number 1, because we're number 1. Now let's permit, and the inside network IPs will be 192.168.12.0. 0 is the network address for the default Class C subnet address. And now we need the wildcard mask. The wildcard mask is sort of the opposite of the net mask, and this is going to be 0.0.0.255. So we know that a Class C network has the first 3 octets reserved for the network. So the last octet is reserved for hosts. We want to tell them that any host within our own network can use from the pool, but no hosts from outside of the network can do that. So that is essentially what the wildcard mask does. So once we hit enter, we can then link the pool with the access list. This is done with IP NAT inside source list, followed by the access list number, which is 1, pool, and the name of the pool, which is my pool. And you can hit enter after that. Once that's done, we just need to define which interfaces are inside or outside. Let's start with the inside interface. So let's go back to interface G00. And this is going to be configured with IP NAT inside. Let's go exit, and let's do the outside interface. Interface S010, IP NAT outside. Enter. And now let's hit Control Z, and we will do copy running configuration to startup configuration. Enter. And that will save our work. Now, as a test, let's go and let's ping the ISP router from the web server. And if that works correctly, then our network address translation has been set up, because we did not configure any sort of routing protocols, router RIP, EIGRP, or anything like that, which would be able to carry that ping from router A to the ISP router. So we know that if network address translation is configured properly, that we should be able to ping the ISP router. So let's pull up our web server. Let's go to desktop, command prompt, and let's ping 200.95.95.2. And if all is correct, we get our replies, and that is how you configure dynamic network address translation. Thank you for watching.